All right, so we have our coding by hand here. Once again, we're just going to go over it in this video. So if you have any questions, you can kind of compare your answers, make sure you did it correctly. And then there's a short quiz that's just going to ask for a couple of the random answers here. Answer those correctly, and you'll get full credits for doing it. Once again, feel free to watch this entire video before you submit so that you know your answers are correct and get 100% on it. As we go through this, once again, the video might be a little bit long. They typically are when I go through stuff. But just note that I'm giving as many helpful hints and tricks as I possibly can. I know this is weird doing online and watching the video about how to do this and whatnot. It's hard for me as well to explain stuff that I'm used to being in a discussion format for me to just say it and just keep talking about it. Not seeing faces on if you understand it or not. So bear with me, skip through some stuff if you already understand it and want to move on quicker than what I'm moving to. So the first thing is here for part A, it wants you to show the memory simulation. And we've done something similar to this in adhesive where we call it tracing code. This is going to be essential, especially if this stuff doesn't come super easy to you. So if you need to kind of go through it slowly, this is going to be an essential step. And in fact, every time I code, I'll code a piece of something, I'll hit run to see if it's working correctly. And if it is, great. But if it's not, and it's not just a simple error, and it's giving me some weird output that I don't understand, then I myself am going to go through, trace through the code, and find out what the error is. And typically you can figure it out by tracing your code. So it's a very, very, very good skill to get used to. So for this loop, we're going to start with while loops. And my first question is going to be, when do we use a while loop? And this is just going to be whenever there's a time when we don't know exactly how many times we're going to run the loop. So it could be that we're asking somebody if they want to play again, or we're asking for user input. And depending on that user input, we may run the loop again or we may not. We could also use a while loop for some type of variable. So we're going to run this until that variable happens to be the correct answer. So it could be like a random number, right? We want to run this until we get a random number between 1 and 10, or something like that. So it's going to be something where we're going to run this until something changes that, until something happens. And that could be with user input, it could be with a variable, it could be with a Boolean statement, something being true or false. It could be finally getting an answer we need. So let's look at number 1, int count equals 0. So I'm going to start with 0 as my tracing the code. And so now I got to ask myself, is 0 less than 3? Yes, it is. So we're going to run the loop. Count is going to increase to 1, and then it wants me to print what count is currently right now. Well, I look at my memory simulation, and I see that count is at 1, so this is going to print the number 1. I get to the end of my loop, and so then I'm going to go back to my loop and check to see if I run it again. So it says count is less than 3. Once again, I check to see what count is at. Count is at 1. So therefore, I am going to run this code again, because 1 is less than 3. So count is going to increment up to 2. And then I'm going to print out what the current value is, which is 2. My loop ends. So then I test it again to see if I'm going to run it. So is 2 less than 3? Yes, it is. So I'm going to run the entire loop again. So count increments to 3. And then I print out count and a space. All right, so my loop finished. I go back and I check it. And I say, is 3 less than 3? It is not. So then that loop's going to end. And we're going to move on to any code that may have been after that bracket. So the last value of count for this one is going to be 3. And it's going to output 1 space, 2 space, 3 space there. 2 is pretty similar, only you'll notice that we switched these 2 lines of code. So now we're printing count out before we increment it. And we'll see how that changes what we're doing here. So count stays at 0, or starts at 0, sorry. And then is 0 less than 3? Yes, it is. So that means we're going to print out what our count variable is right now, which if I look at what it is, it's currently at 0. So I print a 0, I print a space, and then it tells me to increment my count. So we will increment that to a 1. My loop ends. So then I go back here and I say, let's see if we do this again. Is 1 less than 3? Yes, it is. So we're going to run this again. We're going to print out what our count variable currently is, which is a 1, and we're going to increment it. Okay, I finished my loop. So then I go back up there and I'd say, is 2 less than 3? Yes, it is. So let's run this loop again. That means I'm going to print out what the count currently is, which is 2. I'm going to increment count. And then my loop ends. So we go back up. Is 3 less than 3? It is not. So we're done here. So my last value of count is going to be 3, even though we never printed it. That it does get to 3, so we know that. So take a look at those, how those differ, just basically depending if you increment first, then print, or if you print, then increment. You definitely get a different output based on how you do that one. All right, question 3 and 4 are going to be very similar to this, only now you can see that we are starting at 1. So my count variable is going to start at 1. I'm going to just put these two out here. Once again, they are very, very, very similar to those other two, and you can kind of see if you got them right or wrong based on the answers. All right, so notice we start our count variable at 1, so only 2 things are going to print each time. And once again, they'll vary based on whatever part of the code came first. So if we increment, then print, versus if we print, then increment. All right, this is also very similar here, questions 5 and 6. Notice we have a less than or equal to symbol here that we're working with. So once again, go ahead and pause the video, come back and see how you did on questions 5 and 6. All right, so these are going to have 4 outputs this time because we are going to less than or equal to 3, which is going to give us that extra input when 3 equals 3. So you can see that, once again, depending on if the count increment is first and the print is second, or vice versa, it's going to depend what it will actually print. And once again, last one, these are very similar to the first few. So go ahead and pause the video and see how he did. All right, and so here are these 2 answers. Once again, hopefully you did pretty well on this. All right, so for the for loops here, they look a little bit different. We'll talk about that in just a second. My first question here for you for loops is, when do we use a for loop? So when would we use a for loop when instead of using a while loop? And the easy answer for this one is you're going to use a for loop when you know exactly how many times you want your loop to run. So let's say we want this to cycle through the alphabet, we would run it exactly 26 times. If we want it to run exactly through the length of a word, such as assignment 4, during our string shortener assignment, or the length of a sentence, then we're going to use for loops for that because we know exactly how many letters are in that sentence. All right, so getting back to it, so we've got 3 parts of a for loop. So the first part is our beginning value. So that tells us kind of the starter beginning value of our loop. Okay, we have the while loop portion. So this for loop is going to run while that is true, which those 2 parts, that and a while loop, are very, very, very similar. And then the last part of the for loop is going to be what is going to change when we finish running a part of the for loop. So a full increment of the for loop, then what's going to change after that. So let's take a look at some of these. So for int count equals 0, count is less than or equal to 10, and then count plus plus, we're going to do this. And how many times is this loop going to run? Notice that there aren't any brackets here. There should definitely be brackets. But just like an if statement, if there's only one piece of code, you technically don't need brackets, even though it's much, much, much better coding practice to actually include the brackets in it. And this is going to be answer C. This is going to run exactly 11 times. Because if I trace my code here, we know count starts at 0. And I'm going to go to 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And when we get to 11, that's going to break our loop, right? 11 is not less than or equal to 10. So that's not going to be part of the loop. But if I do count these numbers here, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 times this loop is going to run. All right, next question. How many iterations does the following for loop execute? Count equals 11. And when this loop is going to run while our count is less than or equal to 10. So we have to ask ourselves, is 11 less than or equal to 10? The answer to that is no. So this is actually going to be D, none. It's not going to run once because this while statement is currently false. So even before we get to this decrementing the counter, it's going to be like, this loop is over. We don't have to do anything else, and it's not even going to get to that point. All right, question 3. How many iterations does the following for loop execute? All right, so we have count at 0, and we want count to be less than or equal to 10. So right away, this is looking like a lot better than part 2. And then we're going to decrease the count variable each time. So then count will become -1, -2, and so on. And I think very quickly you can see that all those numbers, -1, -2, and so on, are in fact less than or equal to 10. So this is going to be an infinite loop. We're going to have E here, where this code is just going to keep running and running and running until basically we run out of numbers. So that's why computers sometimes get overworked a little bit. All right, question 4, write the heading. For a for statement whose loop control variable y starts at 50, decrements by -2, and stops the loop when y reaches 10. So go ahead, pause the video, and see how you do. All right, so the first part is our starting variable. So it says whose loop control variable y starts at 50. So our starting variable is going to be y, and it's going to start at the value of 50. So we're going to say that means it's an int y equals 50. After we finish a part of our for loop, we put a semicolon. And now we want to see how long is this going to run. Remember, this is like your while statement here. And it's going to stop the loop when y reaches 10. So this is going to keep running while y is greater than 10. And as soon as we become equal to 10, then it's going to stop. So that would make that untrue, which would break the loop then. All right, and the last part is what are we going to do to y each time so that we can get from 50 to 10 without it being an infinite loop. And this is just going to be our decrement y minus equals 2. And just a reminder, that's the same thing as saying y equals y minus 2. All right, there is our for loop. So remember, it's composed of 3 parts. That beginning value, the while statement, and then what it's going to change by each time we finish running the loop. Number 5, rewrite the following while loop as a for loop. Note that all variables are type int. All right, so once again, go ahead and pause the video. When you come back, you'll just see the answer up on the board. All right, so here we go. We have a for statement, so count equals -10. That's given to us right there. While count is less than or equal to 10, which once again comes from our while loop, we're going to count plus plus. So we're going to increment our count variable each time so that eventually we will break the loop and we're not going to have an infinite loop here. All right, and so then the last part is just what are we going to do? And this is just sum plus equals count. You could have definitely written this line of code word for word, so sum equals sum plus count. That's fine, but that's not quite as efficient as using the plus equals. So feel free to use whatever you want, but that plus equals is what you want to get into a habit of using. All right, and the trickiest page here is going to be looking at for loops and exactly what they're going to run. So, number one, we know that we have ints that are limit and count, and we know limit is going to start at 8. So system.out.print gr. So we are going to print gr. And it says for count equals 10. So my count variable is at 10. And this loop is going to run so that count is less than or equal to limit. So in this case, I can look over here and see count is 10, limit is 8. So this is going to run while count 10 is less than or equal to 8. And if you do know something about math, you do know that 10 is not less than or equal to 8. So therefore, this loop is actually not even going to run. Remember, there are invisible parentheses around the one line of code there. So it means that this line of code is actually not even going to run since since my loop never actually ran either. So it's going to skip that and just go on to the NLEE. All right, number 2. This is pretty similar, a little similar at least. So we're going to start with a limit value of 10. And this time my count is going to start at 8. So it's going to print the GR. It's going to get down to the loop here. And it's going to ask you, is 8 less than or equal to 10? And the answer to that is obviously yes. So then it's going to print an E. At that point, count is also going to increment. So then count becomes 9. And it's going to say, hey, is 9 less than or equal to 10? Yes, it is. We're going to print an E. That loop finished it running. Count is going to increment since we finished running the loop. We're going to say, is 10 less than or equal to 10? Of course it is, so then let's do the whole loop, which is going to print out another E. At this point, we increment because we got to the end of the loop. So then count is going to become 11. And is 11 less than or equal to 10? No, it's not. So we're actually done with it there. So then we're going to be done with the for loop. And let's run to system.out.println NLEE. All right, number 3. All right, so here we know total equals 0, count equals 2. And this for loop looks a little weird. Notice we're missing something here before that first semicolon. And this is actually an okay way to code. Personally, I don't prefer it, and I think you're going to make more errors if you do it. But this line of code could easily have just been in there. It wasn't, that's okay. But as long as we know what that initial value is somewhere in the code, we're going to be okay. All right, so is 2 less than or equal to 5? Yes, it is. So then we are going to run this line of code. which is going to say total, which is currently 0, plus 2 times count, which is 2. So order of operations is going to do the multiplication first. 2 times 2 is 4. 4 plus 0 is just going to be 4. And total becomes 4. All right, so now that we've finished that, our loop is going to run again, which means this time now we're going to ask it is 2 less than or equal to 5. Sorry, we incremented counter, my bad. Since we finished running the entire loop, we got to this semicolon. We now then move to incrementing count and seeing if we're going to run that loop again. So is 3 less than or equal to 5? And the answer to that is yes, so we can run the loop. Now let's get just a little bit confusing here. So we have 4 plus 2 times that count, where count is at 3. So 2 times 3 is 6, 6 plus 4 is 10. All right, then we're going to continue with this. Erase this mess. We finished our loop, so count increments. Is 4 less than or equal to 5? Yes, it is. So then let's run the math. 2 times count, which is 4, so 2 times 4 is 8. And 8 plus 10 is going to be 18. So that becomes my new total. We finished running the loop, so we're going to increment count to 5. Is 5 less than or equal to 5? Yes, it is. So we're going to run this one more time. 5 times 2 is 10. 10 plus 18, which is our current total, is going to be 28. We finish running the loop. Count will increment to 6. And then we are going to be done because 6 is no longer less than or equal to 5. So my final answer here for printing will be 28. All right, number 4, what's output by the following code fragment? So here we have 4 count equals 1, count is greater than 4, count plus plus. But just be careful here because count equals 1, and is 1 greater than 4? It's not. So this is never going to run, and we'll get the word end. So for number 4, my answer to this is end. And number 5, write the output of the following code fragment again. So this one is going to print hello, hi, and bye. Notice here that it's just a little bit weird with the semicolon here. What is actually going to run here and count, they do have us to trace the code. Count starts at 1. Literally Java is going to run this line, count equals 1. Okay, so 1. And then count less than or equal to 3. Okay, 1 is less than or equal to 3. And then we increment count. But we have a semicolon, which means this line ends. So it means it's not going to actually do anything. It's just picking out these problems. So then count's going to go to 2, since we increment count. 2 is less than or equal to 3. That's a check, but not super helpful. So then we can go to plus plus again. We've been at 2, we've been at 3. Okay. But we have this semicolon we need to talk about, right? So this loop is going to run just by itself. So count's going to get to 3, and then count's actually going to go all the way to 4. But there's no code here to run, so it's not actually going to do anything. It's just going to increment count until it gets to not be less than or equal to 3. So cool. After count gets to 4, then we're going to start actually looking at this line of code, which should not be indented that far, which is where the high comes in. This is just a normal system.out.print here, the way they have it set up. And then the last thing it's going to print is just bye. So it's going to print hello, hi, and then bye. All right, that is the coding by hand. Once again, I know it was probably a pretty long process, but hopefully some of those bits and pieces were helpful for you.